Hey dudes. Okay, so gonna start my timer here. Why does that sound so quiet? Oh, my battery. Where's it? No, yeah, my battery is totally dying on here. Damn. I got buku batteries though. Damn. I don't know if it's gonna make it through. So we're gonna do 68 minutes. Um, Batteries, cheap batteries. Probably worth the price though. Anyway, so I got my stream fixed. It was shit quality. The video, the audio, it was all trash. Because I got my new headphones set up, and now like I'm pretty sure it wasn't actually my headphones that were the problem. I done already threw them in the trash, and oh well, life goes on, right? Um, it was actually like my setup, the way I had it set up. But it's neither here nor there. Okay, so what we're gonna do is we're gonna pick up where we left off. We're gonna do some coding, obviously, because that's what I do when I stream. Is I code. So we're gonna go to Claude. Claude doesn't give us a lot of tokens, tries, whatever. I don't know what you call that. Anywho, we're gonna pick up where we had left off. And why is this off center? It should be centered. Okay, cool. Alright, so let's go first of all and check our extensions, and it looks like we don't have any like little bubble number there to show that we need to update it. Let's get my highlighter running for the cursor, and we're gonna go to devlog, things to do, div them separate. Where'd it go? Because I didn't click hard enough. Let's minimize this terminal a little bit. And actually, I don't even need split screen. I don't know why I had split screen. Been a while, guys. Okay, so let's multiply this terminal. Control Shift F5 it, or Control Shift 5, not F5. And yeah, I didn't actually finish my devlog here. I made my computer freeze because I'm an idiot, and it's a dinosaur, and I bumped it the wrong way. And when you bump it the wrong way, it literally freezes. Actually, like if you bump it physically, it will freeze because there's like a short with my mounting screws on my motherboard. I'm not worried about it. Like it's, as long as you don't kick it hard, it's fine. It pretty much never happens. So whatever. We did do some work though. We got an hour in, and we continued working on adding in, or rather, we continued working on deciding which features needed to be added to the project. And I am not sure exactly what we decided specifically. I'm pretty sure I ended up deciding that I would need to have a menu screen feature prior to having the reconnect feature. Like the reconnect feature is going to require the reconnect feature is going to require the menu screen. And we'll dive into that a little bit more, but I'm pretty certain that is like correct. That is true. That we will need that before we can have a solid reconnect system. Otherwise, we would have to redo the reconnect system. And we'll dive into that a little bit more. So I don't want to, obviously, I said this before, I don't want to create something that I'm just going to throw away. I want to just make it right the first time. We'll dive into that a little. Redo it. Okay, so here we go. And this can just be full screen. We'll just tab from to and from it. Yeah, so we were going to do a game test. So we should do cd canasta main to change directories in all of our terminals, and then I'm going to try to run the server, and we're going to try to run the client, but it's not going to let me because we have I'm going to go ahead and ghetto rig this code real quick so that we can do this test, because that is actually the number one most important thing, is making sure the game is not broken. So we have this else here, and it's expected an indented block after else statement on line 193. Okay, right. So let me look at this a little closer. Just kind of dipping my hands in a few different files here to set up this reconnect feature, and we might have to we might have to pause on that based on the assessment I made yesterday, or day before yesterday rather. So we're in the server file, like where are we at here? We're in server. We're accepting clients. Okay, so this is for subsequent connections whenever player DCs determines which con to assign client to. Okay, I remember where we were. And in the else, meaning if it's a reconnect but the reconnecting client has a new IP address, we need to have, and this is not being capitalized, it's going to drive me insane, so we're going to do that. This is if C1 online, so then we can we can deduce it, but if somehow both clients are offline, okay, so reading this, I'm like, we're gonna need to add the unique save file client ID, and we are gonna add that. Like we definitely need it. I'm pretty sure, because whenever we get a crash, we lose all the data that is retained through this script. Currently, we don't have any save file. We do have a save file. Like the save file though doesn't have anything in it right now. We don't actually use the save file. So whenever client side the script crashes, the client script that is, all the data associated with the client is lost. We could have the same IP address, and that's what this section accounts for. It basically checks to see if the address is the same whenever they go to reconnect. But since sometimes they would have a new IP address, then that means we have to have, we can't check the IP address, we have to check something else. So that's why we're going to create the save file data structure, the data structure inside the save file. It's just going to be a integer called the unique save file client ID, and yeah, it's a very descriptive name, unique save file client ID. So ultimately, this section would be replaced with checking that unique save file client ID. We would basically just never check the address because, I mean, it's easier for one thing to just check that ID from the file. So, thinking about the logistics of this here, and I'm gonna zoom out and just like talk through this real quick before I go any further. This is just what you have to do. This is the brainstorming section. You have to talk through it. As much as I want to just go in and code, I need to think about this again to make sure I'm like, I got this right. So first of all, let me address this one more time to make sure I'm understanding our requirements correctly here. So the goal is to have the feature for reconnecting, which works as follows. When the client gets disconnected for whatever reason, your internet crashes, your whatever, your cat chews through your Ethernet cord, whatever. When the client disconnects, we want it not to kill the entire application. It's like I use Overwatch as an example because that's like the only game I really play anymore. But World of Warcraft, like I can Call of Duty, like almost all games are like this, right? Whenever you disconnected, it doesn't end the application. It brings you to like a main menu screen and says, "Hey, you disconnected." And that's what we want to happen. So that's going to happen on the client side, obviously. And the way that, like, and my question before was, do we actually have to have the menu screen implemented prior to the reconnect system being implemented? Because that was what I was focusing on, was the reconnect thing. I was kind of like leaning in that, and I was like, well, I might not be able to do that the right way yet if I want to do it with a menu screen, you know what I mean? Because I don't have the menu screen implemented. So do I actually need the menu screen before I had the reconnect system? I don't really want to do this. I don't like doing paint because I feel like I'm really slow with it. I might need to use paint though. If I can't like visualize it up here, you know what I mean? Sometimes it's much faster to just visualize it right here. And then sometimes I can't do that correctly. Let me try. Let me try to do this all in the brain. So the client is connected. The game is started. Client disconnects. Okay. Client side. That means, so let's just go over to client real quick. So we would be, just move this out of the way. Let's look at this. This as well. Get a little bigger. All right. So we have the if name is equal to main. So this is our this is the client file. This is what happens when we run the client script. They try to connect. They get connected to the server that is. Now the client and the server are speaking to one another. And then we assign client IDs. We assign like other things based on our client ID. And then we enter into the main while loop. So like we could disconnect. We could have a disconnect basically anytime after the connect. So that would be from this line 322 all the way through this. So yeah, so like all this is just the main while loop. I don't really need to look at it. I'm thinking big picture here right now. And then we get to the end of the main while loop. This try except, let's see. Okay, so this is the try except. Is there a way to jump to the like associated except? Not officially, but that worked. So yeah, we have one try, one except. Now, like, basically what would happen is, currently, it would, I didn't mean to go all the way up here. I should create a bookmark. So we'll do Control Alt Z to create a bookmark. It's storming over here. It's like on and off. So it's gonna enter into this try, and then when it disconnects, it's going to hit this accept right here. Okay. Now, in that case, currently the script's done with. There's no like, there's no way to continue running it. You have to run the client script again. And I think the Pythonic way, I think like the correct way, I don't think the correct way would be to like cause the script to be reinitiated again. I think, well, obviously, the correct thing to do would be to somehow make it to where whenever we disconnected, it will, and we can just put this in a comment form. So this is what we're doing. We're going a little further than just regular brainstorming. We're gonna add in some notes. I'm gonna put the date so that I know, like, I kind of want these notes to be together, for like today's notes. This is like brainstorm. So I'll just like put a little title. We'll call it Reconnect Brainstorm. How about that? We'll just call it Reconnect Brainstorm. And then there we go. Now we have our date, and we'll say, okay, we want to, and I'm going to copy this because I'm going to be like reusing this. Can't you have multiple things added to your clipboard? That's something I want to look up real quick. Like, just in general with Google or whatever, can you have multiple text? Can you have multiple? They never give you enough time. Yes, multiple means having more than one. Can you have multiple? Can you have multiple? No, you can only have singular, obviously. No? Can? No. Aha. Man, the answer is no. Right. Can you have multiple objects, text snippets in your clipboard using Control-C on Windows? Look, they don't give you enough time. Like, you have to have it pre-written like a script. Yes, you can have multiple text snippets in your Windows clipboard by repeatedly using Control-C to copy clipboard history feature allows you to access and paste history. Yeah, but like history up to 25 entries. To view and paste, yeah, but you can only use it's like different text names and first question. I mean, what are we talking about here, dude? We're talking about a text file where you. I know, it's silly. It's a silly question. Sorry, forgive me. I was thinking something like a app that, something like an add-on that allowed you to shuffle between things that are in your clipboard and choose which one you want to use. You know, like you just hit like a certain keybind, like Control Shift A, and then you get this little window pop up, and it shows like all the things in your clipboard, and then you hold Control Shift A and you do up and down to like choose the one that you want, and then like that's your chosen snippet, and then you paste dynamically what you know based on what you want to choose from your clipboard. Anyway, I'm almost certain something exists like this, and I'll just add this to my desktop. I'm not gonna like worry about looking at it right now. But we'll put dynamic. I love that word, dynamic, man. That's my word, bro. Dynamic clipboard paster add-on. I don't know what you call that. Whatever. Okay, we'll worry about that another time. Reconnect, brainstorm. So we just have this copied snippet, and when we hit this accept, like we want to reconnect and begin main while loop again. So that obviously that entails a lot more. There's a lot packed into that little statement right there. Reconnect and begin main while loop. So did it again. Let's do Control Alt N. There we go. So we want to basically just come back to this point right here. We want it to, whenever it hits that accept, so basically we would like put all this within a function, and we would call the function, we would try to run the function, and then when we accept, we just would run the function again, but that would only happen once. So we would actually need like a while, basically we need a while loop, and basically like while we could just have it be a while true, and yeah, but an exception, that's not gonna work, because an exception is going to exception is gonna break out of the while loop, right? Well, no, not if the while is outside of the try except, it is outside of the try except. When you hit that exception, the while loop is still gonna run, right? Am I thinking of this correctly? So let's go down here, and let me just like kind of write this out here. So we have, let's just say while true, okay, and then we'll call this let's call it client side loop, okay, as a function. And now let's say within the CS loop we have the try except within it. So whenever we hit the exception right here, we would basically like do nothing, right? And it would but by the nature of this while true loop, it's going to loop again. It's gonna call this function again rather, and that's gonna bring us back to. Whoops. I keep hitting the wrong button here. I keep hitting Control Alt Z. Oh, it jumps between files. Whoops. Whoops. All right. So then it's gonna jump back here, and I mean, like, yeah, that's what we want, right? I feel like I want to keep it simple, you know. I want it to be simple. Simple is great. Like, complicated is bad. Simple is good. I would rather it like rerun the entire thing and work from that like premise. I want that to be like a rule, you know what I mean? Like, I don't want to jump in at a certain point, you know, in this loop and rerun like this section. No, we just rerun the whole thing, and I feel like that would be the way to go, because it would just. So let's talk through this. You're playing, you're connected. You go here, bam, you run the client script, bam, you hit this line, bam, you connect, bam, you're playing the game, bam, you disconnect. Now, you know, because we're in this first iteration of the CS loop. Then within it, bam, we hit that accept because we had a connection error, right? And then, you know, currently we have this logging. We would probably move the logging to be move logging that's currently in except to be here instead, right? Because we don't want it to print the log just because we had a DC part of the script run. We want the logs to print out after the script is like being terminated, and in this case it would be relocated to here. Anyway, so yeah, and then so now we're disconnected, and it's gonna then jump back to it's gonna jump back here, and it's gonna connect, or it's gonna try to connect, and I'm pretty sure. See, now I don't want it to just like through this. I'm pretty sure end connect is blocking. Like, I want to say, let's see, we already have network open, so we don't need to it. So we have end connect, and it's self network socket connect. Damn, there goes the storm. It's just like downpour, bro. It comes and then it goes. It's very strange. Anyway, so we have def connect, self network socket connect, and is network socket connect blocking? Ah, damn, like, I'm telling you, like, it's like not raining, and then it's like fucking mad raining, dude. It's like pissed raining. Like, it's coming down, bro. Alright, so we're gonna say Python s connect is blocking. And it's smart, dude. Claude's gonna know what I mean right here. You can speak like in ghetto English to it, and it will know what you're saying. Yes, the socket connect method in Python is blocking by default. When you call connect, it will wait until either the connection is successfully established, the connection attempt fails, or the socket times out if a timeout was set. If you need non-blocking behavior, you have a few options. So default, it's blocking. So if you did set blocking to false, it would change that. Connect X host port. Okay, so that's just connect. Use timeout S. Set timeout 5 second timeout. Connect. What is connect X? Use async wait is a modern approach. Async with await, async IO open connection. Host port as reader writer. Okay, so async with await, like I don't use async. I have not used async. I had learned this a few times and I always forget it. There's like multi-threading and then asynchronous. Asynchronous is like async is not multi-processing, right? Like async is a library. Like it's not a well. I mean, so it's like multi-threading and multi-processing. I didn't want to do this. I didn't, but like when I see a term and I don't know what it means, I have to know. I have to remember. Like, and I've learned this before. Connect X is similar to connect, but returns an error code. Returns the error code instead of raising an exception. It's returns an error code instead of raising an exception. It's particularly useful for non-blocking sockets. Returns 0 if. Okay, it returns a code instead of raising an exception. Okay, that's kind of cool. I get that. 0 if connection is successful. Error code if not successful. In progress. Error. Okay, gotcha. All right. Common usage pattern. Especially when building event-driven applications or when you need to handle multiple connections without blocking. Okay, and then async with await. The async with await syntax is used for asynchronous context management in Python. Import async IO, async def connect server. Reader, writer, await async IO open connection. Async with writer automatically closes writer when done. Send data. Writer write hello server. Await writer train. Ensure data is sent. Read response data equals await reader read. Async with ensures proper cleanup. Await pauses execution until the async operation completes. So I want to say this is like waits like, but if you used async, then it will like do this stuff while it does other things. Is that right? Is something like that? This is much cleaner than managing raw sockets and provides built-in error handling and resource cleanup. So async allows you to do multiple tasks simultaneously, while await will pause until another async task is complete. Something like that, right? Is that sort of how it works? Let me break it down. Async marks a function as Async marks a function as a coroutine, which means it can be paused and resumed. It doesn't actually run tasks simultaneously by itself. It just makes the function eligible for asynchronous execution. So await is where the magic happens. When you await something, the current coroutine pauses, control returns to the event loop. The event loop can run other coroutines while waiting. So you have an event loop with multiple coroutines. When you await something, the current coroutine pauses, and then the event loop can run other coroutines while waiting. So it's waiting for a task to complete. And so it's like whenever you hit a blocking operation, while it's blocking, it's like now you go do this while this is blocking. And once the awaited operation completes, the original coroutine resumes. And then it picks up where it left off. Ah, see, okay. This now I understand. This is kind of important, like for me to learn, because there's been multiple times in programming, and I'm not sure if I understand this correctly, like fully, but I want to say there was multiple times when I was coding and I was like, how do I make something like pick up in the middle of a function? You know, like let's say something happens and an exception or something, and like when that exception happens, or when a certain event happens, we want to break out of that code block at that point. It's like at that exact line, and then execute some task. We could say like reconnecting. Let's say you disconnect, and then at a certain point that runs another coroutine, we'll call it, just as they call it, and that like reconnects you, and then it picks right back up. It goes back to that spot where you previously were in like this broader, to say you're running a delicate loop that you can't just like start from the beginning of that loop when you break out of it. You have to like pick up at this exact spot because of just, you know, like how delicate everything is. So this, I think, is a way to accomplish that. Now I could be wrong, like I might be not understanding it completely. Like it might not work in that way where like I'm my brain is like in the dark, you know, like you're in a dark room and you're like feeling an object and you're like, hold up, wait a second, like this is actually something that I might need to know. This, like, this is important, and my brain is touching it, and it's like, wait a second, this is good, this is something that I have been looking for. I might actually be able to use this, but I've kind of stayed away from async IO, I think, because it is another level of complexity. Like it is definitely adds another like layer of complexity when you have like multi-threading, and then you have client server, and you have like event handling, and you know, you have a lot of things going on. To add in like async, that's kind of like another It's another level of complexity, and I'm not necessarily sure that async IO would be the answer. Like, I actually think, I hate to say this, I don't want like to believe this, but I had been working through like mentally on this eventual feature that I was going to add in, which is the perfect save system, which connects to the reconnect system, wherein when you reconnect, there all your data, it's restored exactly as it was. Just like, whenever you're in a Call of Duty match and you get disconnected from the Call of Duty match, when you reconnect back to the match, you're not like a minute behind all the other players. Like, you jump in, let's say your level is retained, your rank, like your weapons, like where you were located physically, you would spawn back in like exactly where you were, you know what I mean, as you were. Like, it would be a perfect reinsertion into the game, as to where, like, currently, if you disconnected and you entered back in, like, the while loop is so extensive and there's so many different things that happen. It would be, I have like tried to imagine a world in which you can just pop back in and start that loop over and everything is fine. But like, that might be true. It could be true. It might be true. But like, I am just pretty sure. I'm not certain, but it's like I'm convinced that there's a high likelihood that unless you picked up like exactly where you had left off, um, there might be some strange behavior. Like, and this is a complicated thing. This is not just like 1 + 1 = 2. This is a pretty complicated process. It's a complicated process to think about whether or not I actually need that, or like. But I feel like I should take a minute, and I will at least, at the very least, here's what I'll do. I'm gonna add it to my things to do to look more closely at async, to see if I can use it in the way that I'm thinking. Let me look at this example real quick. So we have, I'm drinking coffee way too late, dude. Way too late, bro. Drinking coffee way too late, guys. So we have import async dev make coffee. Definitely make coffee. Dev do it. Make the coffee. So you start the copy. You start the copy. Coffee. You're starting it. Now you await, and it simulates the brewing time. Async IO sleep. So you sleep for 3 seconds. Okay. You run a 3-second task, and then print coffee ready. Return to coffee. Okay. Then you have def make toast. Starting toast. Async IO sleep. 2-second task. Blah blah blah. Breakfast. So now you have this function called async def breakfast. So then you have the coffee task, which is async IO create task using make coffee. Yeah, now see how there's levels of complexity to this. It's not just like 1 + 1 = 2. It's even kind of complicated doing it with just these little simple functions. It's a lot more complicated when you're like using bigger and badder scenarios. Um, anyway, so you start you start to make the coffee first, and then you well actually this is just creating the coroutines and assigning them to this namespace coffee task, toast task. So you have your two coroutines using each associated function, and then we have where the magic is going to happen. So we have coffee. We don't actually have to. I don't think you have to assign it to a variable. You could just say await coffee task. But anyway, so you have coffee equals await coffee task, then toast equals await toast task, and then print breakfast is ready, coffee toast. And then there's another a layer to make this work, is you have to do async IO run breakfast. Okay, so it's a little bit complicated. When you do this, both coffee and toast start simultaneously. So when you do async IO run breakfast, you're running this function, but you're running it in the context of async IO run method, which is basically going to allow you to like, I don't know if that was hail. Anyway, there is it's going to allow you to start the coffee task and the toast task simultaneously. Like obviously one of them is going to start first, but there's no waiting going on. It's going to allow you to asynchronously, which is like, at the same time. And so it's kind of weird though, because it doesn't synchronized means like asynchronous meaning. Asynchronous is not existing or happening at the same time, which is like the opposite, right? Shouldn't it be called synchronous? Of or requiring a form of computer control timing protocol in which a specific operation begins upon receipt of an indication or signal that the preceding operation has been completed. Okay, so the asynchronous is referring to the fact the timing protocol in which a specific operation begins upon receipt of an indication or signal that the preceding operation has been completed. Right, okay, I understand. I see now. So async is not really like parallel in concept to multi-threading and multi-processing. Those are like synchronous. You have two things happening at the same time, as to where asynchronous refers to the fact that one event is gonna be waiting for the other event to complete. It's like a relay race. So instead of two running together, it's like a relay race. You have one task and then the other task. It's how I understand it. I'm pretty sure that's correct. Anyway, so coffee test starts simultaneously toast finish after 2 seconds. Because we did async IO run breakfast, coffee takes 3 seconds. So it starts the coffee, like the series of events here would be, since we do coffee first, it's gonna await, which means it's going to run this line, and once it gets to this await, it's going to go to the next task. It's going to look for the next await. Is that how this works? It's going to look for the next await, which is going to be the toast task. So while this is running, it's going to, so the process would be starting coffee. It's going to hit this sleep. Then it's going to trigger the running of, it's going to go to this line, which is going to do a wait toast task, which is going to do starting toast, and that's going to go to a wait sync IO sleep 2 seconds. And so now this is going on. The 3-second sleep and the 2-second sleep are happening simultaneously. And this is going to finish first because it's only a 2-second operation as to where this is a 3-second operation. So yeah, you get toast finished after 2 seconds, coffee finishes after 3 seconds. The results are available without waiting 5 seconds total. The tasks aren't truly simultaneous. Python's global interpreter lock, or GIL, prevents true parallelism. They're interleaved efficiently by the event loop. This is perfect for I/O bound tasks like operations or file handling. Okay, I'm starting to understand this on a deeper level. It was just as important. I've never really used it. I've always wanted to use async. So what we're gonna do is we're gonna add things to do. I'm gonna put in pressing issues, and we're gonna put using async IO to solve perfect. We'll call it perfect reconnect issue. After seeing async IO brought up, realized it may allow for a solution to the problem of entering back into the main while loop at a particular location whenever it is exited via a disconnect, etc. So yeah, there's a lot there. Like this is not simple. I mean, everything's simple when you understand it. Which means, since I'm saying it's not simple, that means I don't understand it. But you know, it's not 1 + 1 = 2. Anyway, so back to this real quick. I wanted to clarify. Does this happen via multi-threading or multi-processing? How is it simultaneously executed? Or is this done single-threaded, single process? By default, async IO runs on a single thread and single process. This surprises many developers. The simultaneous execution is actually achieved through cooperative multitasking in a single thread using an event loop. So it does, like, I'm trying to understand on a deeper level. Is it just like hopping back and forth between the tasks? Like it's just like hop, you know what I mean? Like, is that what it meant by what was the phrase that it used? Let's see, interleaved efficiently. Is that what it means when you say interleaved efficiently by the event loop? Let's read this a little further. Async IO time threading. Async def task 1. Task 1 thread. Thread name. Async IO sleep 2. Task 2 thread. Async IO sleep 1. Create task 1. async IO. So you create task and you pass in task 1, which is 2 seconds, and then this is a 1 second operation. Then you do await async IO gather, task 1, task 2, start equals time, async IO run main. So now you're running using async IO main, and it's going to initiate this. It's going to do the 2 second sleep. It's going to initiate that once it hits this await keyword. And then it's going to execute the 1 second task. The 1 second task is going to finish first, and the second 2 second task is going to finish second. Everything executes in main thread. Task 1 hits await. It yields control back to the event loop. Okay. So await is the keyword. It yields control back to the event. Event loop starts running task 2. Okay. Yeah, that's important. Event loop manages these yields. When task 2 hits await, it yields back. The total time is 2 seconds, not 3 seconds. This is why I think I was great for IMS, but not CPU. Oh no, I got an electricity flash. It's probably gonna die. It's probably gonna cut off. So I think I use great for IO bound tasks. Network and files. IO bound tasks and network files, but not CPU bound tasks. For CPU bound tasks, you want actual parallelism with multiprocessing or multi-threading. You can async IO with multiprocessing, multi-threading if needed. And that's the level of complexity that I was avoiding. I was trying to just do it without async, because simple is better, complex is bad, simple is good. I don't want to even read that, honestly. I don't even want to read it. Import async IO concurrent futures. CPU bound task heavy computation result equals sum of II for range massive number return result. CPU task in a thread pool. So you would want concurrent futures. Run CPU bound task in a thread pool with concurrent futures thread pool with executor as pool. Result equals await async IO get event loop. Pool executor as pool. Result equals await async IO get event loop run an executor pool CPU bound task. Result. I'm losing it, guys. I'm fucking losing it, dog. I'm falling off. I'm tired. Why'd I wait till the end of the day to code? That's just, I wanted to code. I haven't been coding, and I was like, today I'm gonna code like whatever it takes. And I just can't code when I'm like really tired. I have to be slightly awake to code, which means coffee. So here I am like a dumbass drinking coffee at 8 o'clock. So I'm gonna finish this though. Async def main run CPU bound task in a thread pool. And let me just check my stream real quick, make sure it's not messing up. Make sure we got it's actually working right now. Whoa, man, you don't want to see my YouTube. It's kind of boring, honestly. In a thread pool. Let me just check my stream real quick, make sure it's not messing up. Make sure we got it's actually working right now. Okay, yeah, it is actually working. That's cool. Man, you don't want to see my YouTube. Okay, so where was I? Claude is teaching me. Import async IO import concurrent dot futures async def main with concurrent futures thread pool executor as pool. So this is a new thread. Result equals await async IO get event loop run in executor. With concurrent future start pull executor as pool. Result equals await async get event loop run in executor, passing in pool and CPU bound task, print results, so main, and then you run main using async IO. So he's using await, which is I don't know what this run and executor thing is. Like I don't know what get event loop. I don't understand exactly what's going on here. But then he's basically creating like a new thread, as far as I understand it, to run this CPU bound task or a new process, one or the other. And when he triggers this await keyword, that is going to allow for, like, if he was to have another await keyword process that succeeded this, like after this with part, in between with and print, we'd have another task with await, and like that would allow him to run that new process while this happened. But whenever this process, let's say that process only took like 2 seconds and this one takes like 20, whenever the process down there finishes, it's gonna like it's gonna go back and finish running this, and return that result. If I understand this correctly. So in the example you just gave, you are creating a new thread process using await and running a CPU intensive task. And if you wanted to add another 2-second task succeeding the result task using another await keyword, it would do the 2-second task and then finish up the other first task. Not quite. Let me clarify with an example that demonstrates what happens. I don't need to see another fucking example, dog. I just need plain English. I'm not gonna read all that. I'm not going that deep. The key point is that the await keyword makes things happen sequentially within the same coroutine. If you want them to run concurrently, you need to create separate tasks. Got it. In the second version, the light task will complete while the CPU the run executor. The run in executor creates actual parallelism using thread or process, while async creates a coroutine that runs concurrently but not in parallel. Both methods can be awaited, but they work differently under the hood. Got it. Sort of. I sort of understand. Yeah, that's complicated, dude. So, like, what am I gonna do with this knowledge? Am I gonna retain it? Is it just gonna get thrown away? Hopefully I retain it. I kind of wanted to drill it in to understand this async because I always get confused about it. Interlead efficiently by the event loop. Does this mean the CPU switches between tasks intelligently such that the 2 second task and the 5 second task are executed smoothly? Like, I don't really know the word I'm looking for here. Like, the event control. The event controller doesn't actually switch CPU time between tasks. Instead, tasks voluntarily give up control at specific points. Right, but it only takes 5 seconds. It doesn't take 7 seconds. So, like, task only switches to waypoints. It's cooperative. If your task doesn't have any weight, it will block everything else. The event loop is different. Okay, right, but how it simultaneously or pseudo simultaneously executes the tasks such that they are completed in 5 seconds instead of 7 seconds. How is that accomplished? Right, but how simultaneously? Let me break down concretely using an example that shows exactly how the event loop. No, I don't want to see code, bro. Here's exactly what happens. 6 seconds starts when it hits a weight. It tells the event loop, wake me in 2 seconds. And hits point B. So it tells the event loop, wake me in 5 seconds. Then wakes up. So test 2 seconds. It completes after 5 seconds. It wakes up. Yeah, I understand that. The key is that when the task is sleeping, it is not using any CPU time. Then when the task is sleeping or waiting for IO, it is not using any CPU time at all. The event loop is free to run other tasks during that time. This is why it takes 5 seconds total instead of 7. See what happens in parallel, even though the code runs. Where tasks spend most of their time waiting rather than computing. Oh. Okay, now now I see. Okay, I understand. I'm understanding. I didn't understand. I didn't actually understand. I am understanding now. Okay. Okay. I get it. I see. Okay. So it was not what I was thinking. I understand much better now. So it's 68 minutes. I'm gonna take a little break. Honestly, I'm probably gonna quit. It's late. Like, I just waited too late. I waited too late. I do want to do a little bit more, but we'll see. I'm gonna take a 5-minute break, and it might turn into the end of the stream. We'll see. Maybe I'll be back. Maybe I won't. If you see me, you see me. If you don't, I'm going to play Overwatch or something. Okay. Now you see me, now you don't. Okay, so yeah, 1 hour. I'm guys, I'm done. Cashed out. Just I'm gonna close it out here. So ultimately, I understand uh, async. I await a lot better now. Um, ultimately, I don't. I'm not gonna lie. I don't completely understand it like fully. Like I do, but I don't. I'm kind of confused about like the waiting part. Like I don't necessarily think it could be used the way that I was suggesting, but maybe it could. Maybe it could. Like, yeah, I don't know. I'll just write this down though. So like the scenario that I'm imagining in which it would work is like so. Imagined scenario. So in this imagined scenario, we have use await to use await upon DC, which is triggers um, subsequent await, which causes reconnect and reloads all saved data. Um, yeah, feel? You feel what I'm saying there? You get that? You where I'm going here? And so use await upon DC, which triggers subsequent await, which causes reconnect and reloads all saved data, which will like re-initiate the first awaited task main while loop. You know what I mean? Like now, I don't know if this would actually work. Need to analyze functionality of async further. Might not work since relies on waiting time, not computing time. So I don't know. We'll have to figure that out. But that's just kind of like a side issue. That's not really what I wanted to focus on. I wanted to focus on um, the what was my initial question? Like, how did I? Da, 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 da. Let's see. So we have. Okay, we were asking about if socket connect is blocking, right? So in if con connect, so this is blocking, and I'll just put blocking operation. So it's a blocking operation, and so we were looking at the big picture of how we would execute this reconnect, and we have we'll put a bookmark here as well. We have a lot of bookmarks. I need to clear my bookmarks up, but ultimately we're going to say while true, we enter into the CS loop, which is basically this whole file almost, and then the try except is within it. We have the try connect we end up connecting, we hit an exception, which is going to cause we disconnect, which triggers our exception, and then um, since we're in this while true loop, it's going to run this CS loop again. So it actually after, except to be here after above while loop. So then it's just gonna run the CS loop again, which would above snippet allows for reconnect via while loop. Yeah, like that. This is pretty simple, honestly. So yeah, like honestly, I think that would probably be the way to go to accomplish what I'm trying to do. We would do, yeah, we would have upon DC, we just hit our accept, and basically it's just gonna like end the function. The function's just gonna like end, and then it's going to re-enter the loop, but which would reconnect it. What the fuck is this? What is this? No, 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 no. Not that type of shit. No. No, baby. No, baby. No, baby. No. Alright, so what am I doing here? Right, so it enters back in, we reconnect, and then it does all the things. You know, obviously there would have to be some modifications made, like, it would have to be, you know, wouldn't be able to just be left just like this. But I think, like, ultimately, this system of just using the while loop would actually work for, like, having a reconnect on the client side. And we don't need a reconnect on the server side. As far as, like, I can understand this. I mean, the server technically could go down, but like, I think that's a completely different story. Anyway, so this would cause us to be able to disconnect and then reconnect smoothly, just using this while loop. It's very simple, very straightforward. Once we reconnected, we'd hit this line again, and we'd basically have, like, you know, if it's a reconnect, like we have right here, if n reconnect is equal to false. If it's not a reconnect, we run this section. If it is a reconnect, we wouldn't run this, like, little preliminary section, because, you know, let's say, like, we have a well, you know, it's actually, I'm just realizing this, like, if a disconnect doesn't kill the script, then that means all the information that's contained within the script is still retained, right? Like, it's still there. It's not like we don't have to put it in some save file, right? Because the data is still there. Like, all of the game data that we lost from the disconnect wouldn't actually have been lost because the script never actually died. You know what I mean? That contained all the data. So honestly, this kind of changes everything. as far as like the save system, because in that case we wouldn't actually have to save it. It would already be saved. That would be really cool. I mean, like that's actually a huge answer to a big problem that I was trying to figure out a solution to, was how to implement a perfect save system. And now I'm like, well, we already have the perfect save system. It's the state of the game. And as long as we don't lose that data, I was so focused on like, how do we restore the lost data? I wasn't realizing that I could just not lose that data initially by keeping the script alive, which is a really simple solution, and it just proves that my IQ is very low. Unfortunately, you'll probably experience the same thing when you're doing programming, and that's why zooming out and looking at the big picture without any assumptions is very important, and it's easier done than said, though. I mean, it's easier said than done. It's harder to accomplish. To think outside of the box. You get so kind of like focused on a certain train of assumptions, and it's hard to throw away those assumptions, like assuming that the script couldn't just be kept alive. So that's actually a huge potential breakthrough. Granted that it like would work, and that I'm not just like hallucinating here, but I'm pretty sure I'm not hallucinating. If we kept that script alive through the while loop, whenever we disconnected, we wouldn't have to restore any data. The data would already be retained. We would literally just have to, like, the only concern then would be re-entering the while loop at the particular point that it previously was at. Does that make sense? So, like, and as to the initial question of like the broader question of do we need to have the menu screen for this to occur? Like, do we need to have the menu screen feature prior to implement this? And I think actually the answer is no. We don't. I don't think we actually have to have it. We have to account for it, but we don't actually have to have it implemented. You know what I'm saying? Like, it could just be a ghost version, some placeholder code. It's not a requisite. So, so we have while true CS loop, and what was I just saying? The oh yeah, the menu screen. So basically, we'll have. I should have done it like this. Menu screen. So menu screen, then CS loop, and then yeah. So basically, that is the loop. You have the while true, you start at the menu screen, then you run the CS loop, unless you get disconnected. When you get disconnected, it's going to loop through again, and it's going to bring you back to the menu screen. Now, like we could probably have like if reconnect, determine which like part of main while loop to re-enter. Don't know how I would accomplish this. I don't know how I would, make that happen specifically, but that would be the goal, to do that. Bookings currently accept to be here, except after a while. So. Okay, Yeah, so this is good actually. This is a really big success. True menu screen. If reconnect, determine which part of the main while loop tree enter. Um, Potentially could use async IO await, maybe. No, I'm not sure about that, but we'll figure something out. Ultimately, we have got back on track now. Like I know what I need to do, um, and I know what I'm gonna be working on. So we're gonna stop here, and I'll just put our stop right here. 12:20 stops here. In devlog stopped at 6:47 in client. Yeah, baby. Yeah, baby. Yeah, baby. Great, fantastic, beautiful, wonderful, awesome. And now so we go to things to do, and we're gonna say, let's look at current issue, other client DC CS logic. I'm not sure that we have logic placed to alter the game output whenever the client receives the information showing the other client DC. We have logic to alter the game output whenever the client receives the information showing other client DC. Okay. Using async yourself, receive verification logic concerns, menu screen, creating login system, perfect save system, ASCII by ways. Okay, so I need to update this and put update 28:24. Realize that if we use outer while loop in client 5, which runs the we'll just call it menu screen function followed by say outer while loop and clever returns followed by CS loop, client side loop. We would never actually lose the client data because the script would never end. We were previously assuming that the script would terminate, but this avoids that completely. And very simply, so like TLDR, we don't need a perfect save system because the data will never be lost. That's actually huge. Like, man, it's amazing what a little time away can do, and just like a fresh look can do to, like, that's such a big deal. I was so stressed out about that perfect save system. It's kind of embarrassing actually. It is, because all I had to do was add in zoom out and add a while loop before it. Problem solved. Easiest, like literally easiest solution ever to what would have been like one of the most complicated, just please kill me. Literally, I didn't want to work on this project anymore because I was thinking about how complicated the perfect save system was going to be. I was like, literally, just kill me instead. Is that bad? So, okay. Next thing, pressing issues, current issue, pressing issues. Okay, so we'll put we'll just say reconnect, reconnect system. 12:28:24. Determined a simple solution for reconnect logic in client pi. C lines, what is it? 639 to 647. 639 to 647 in client pi for brainstorm. Storm first pass to determined we don't need menu screen in place prior to implementation. We can go ahead and work on that. It's really cool. So we're just gonna move this up to actually to the top spot. This will kind of be like a secondary within the reconnect system solution. This will be a part of it. And using it, you got to see verification, logic concerns, menu screen. See, where was I writing? Okay, perfect save system. SIS, could try a save thread on SS. Could just update, and I'm gonna put this at the top just to make sure like I see this. We don't need a perfect save system. And what was I gonna write? Oh yeah. Implies we may not need the CS save file pickle at all. Awesome. Okay, so yeah, we're gonna stop here and devlog. So we're just gonna go devlog here. We actually went over the hour. We actually almost did 2 hours. So it was an hour and 45, which because I copied and pasted. So we actually started at basically 7, and we went to 8:45. So we did 1.75 hours, and we did continued working on deciding basically same thing, which features need to be decided or determined. We don't need menu screen implemented before, what is it called? Reconnect system. So we don't need the menu screen implemented before reconnect system. We also created simple solution to reconnect system. Client side, C, I. Subline 647 client pi. End of file. Alright, there we go. So you created a simple solution to reconnect system. We created the first pass of simple solution to reconnect system. Cool. So, you know, these things, be encouraged that lots of times you will think something is going to be really complicated and really difficult, and then when you start to work on it, it will seem even more difficult and more complicated. But by the time you actually like really work your way through it, you find out it's actually kind of simple. It's not that complicated. Everything is complicated until you understand it. If you've ever learned any new math concept, like in algebra and stuff, you know that feeling of just being like, oh, I can't do it. It's impossible. Like, literally, I can't. And then you keep trying, and you're like, no, I really can't do this. And then the light bulb goes off, and it's like, whoa, wait a second. I actually can do this. It's not complicated. So, yeah. Anyway, we're done. I'm running out of gas here. So, oh yeah, can't forget about this. I need to I was gonna show you the game. I have too many notes. Let's do Pi server. Literally sounds like there's a war going on outside or something. Else if the games you can play literally. So let's make sure this works because I just want to see it. We'll go to 199 else and then it's expecting an indentated block after 193. Okay, right here. So we'll just put pass right here. That's really all we have to do right now. So we have pass. Now let's try it again. CS save file. Line 11. Client line 11. Okay, so let's go to the top. Right, so we might not need this actually. Still not gonna work. I got a lot of weird shit going on with this reconnect thing. That some code I'm gonna end up having to most likely remove. Let me not be sloppy here. Let me put a note. Actually, I'll do the same thing over here. Just any file over network. We still might need to save that to a file just in case they actually, like, the client itself does crash for whatever reason, like the process, like if the computer crashes, that would kill the script. So we would need, actually, let me write this. I know I'm all over the place, but that's how programming is when you get to this point. You kind of have to be all over the place because there's concurrent thing. There's a lot of things going on, so you have to have a lot of things going on, you know? Creating a login system, perfect save. We don't need perfect save system. Implies we don't need this. On this point, we actually would need it to store that unique save file client ID. Thank you, autocomplete, for that. To store that unique save file client ID for the case in which the computer crashes. Fuck, so now I'm right back where I started. Because if the computer crashes, then you do need the data to be saved. Fuck. Which means you do need to restore it. Which implies we actually would need a perfect save system. God damn it. See how dumb I am? Man! Yeah, so in the case of the computer crash, you're going to lose it, so it would need to be stored. You would have to restore it. I don't think that would be as complicated as I really think it would be. It's doable. It's just going to take time. I don't need to feel like it's the end of the world. You know. It's, you know. We like instant results, you know? Because I've been working on this for so long. It's like as you go further, the further you have to go, and because of just how complicated it gets, that's the project I chose. I have to, you know, I have to eat my words, right? Like I a lot, and I have to chew it all. So, which means we actually need a perfect save system. Idiot. Anyway, import CSA file. So we're gonna put a note here, but we're just gonna comment. I'll put a note. What's our thing? Control. Comment for below line. Line comment created 1226. So that's one of our snippets. And we'll just put comment. It's not 1226. 1228, dude. 1228 commented this out. Commented this out. What the fuck am I doing? Debug and test game before I move further implementing the reconnect system. Okay. All right. So okay. So the server is running right now. So now we're gonna do client. We're gonna run the client, and okay. So we have a bug here, a crash bug at client 349. So let's go there. And okay. So we actually like had to comment this out. So we're gonna go to the top. We're gonna 2, 3, 4, 5, 6 because this is a caution comment. Now we're gonna go back to 349 and we're gonna paste this same exact comment. Right. So now that's commented out. There we go. Bam. It's running, and this is client 1. This is online, and why is it doing that? We're gonna run clients over here. So this is the other client is gonna be connected online. Or not. It's not working. So let's kill the script and try it again. We'll do server, client 1, and there goes client 2. There we go. So we have Joshua, and his name is Merrifield, so his first name playing against the last name. And prepare to play Canasta, prepare to play Canasta. So there we go. We have 2 players. They're online. This is actually working as it's supposed to, and this is online. It's on the machine locally, but it actually is connected through the network. It's not just like pseudo online. This is actually an online operation here. As you can see in the windows down here, the 2 operations are happening. Well, they look visually identical. Normally they kind of don't though. Normally one is a little bit behind the other because of the data transfer delay and all that, but it looks like they're basically concurrent right now. So then we would draw from the stack. That dude goes to play his cards. And it's super loud. So loud. There we go. Bam, 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 bam. Yeah, it took so long to get to this point, and it's working out what melds are eligible for usage, and none of them were after we chose not to use our wildcard. There we go. Now we can discard. We pick a card, discard our 5. Now it's the other player's turn. He gets to draw from the stack. Yeah, it's his turn to play. He's going to play his cards. Select them all. Boom, boom, boom. Place like the cards. And there you go. Now it's let's use a wild card. Let's click yes. What? Oh, it's showing. Okay, never mind. Let's add to the aces. Okay, so we're gonna add the 2 to the aces. There we go. And it's not gonna let you use the black 3. We have a bug with the calculation of the score, which is why it didn't say that was correctly meeting the meld requirement, which it actually was. So, long story short, we had to fix that bug. We're going to discard our black 3 because black 3s are bad. And now it's the other player's turn. And as you can see, so this game actually works. It's basically done for the most part. It just, it needs some visual tune-ups, and it needs like a menu screen and the perfect save system for deconnects and reconnecting, and some other little things that we're going to add eventually. But I just wanted to make sure everything is in place. I wanted to test it because it's just good practice to test before and after your session to make sure that the behavior is the same as it was before you touched it for the day. To make sure you didn't fucking break something, because if you did break something, you don't want to like continue working on what you were working on. You want to say stop everything and look, view the changes you made that day, and then you'll be able to pinpoint, hey, in this little days section of code, instead of not realizing you broke it on day 1 when you're on day 7, and then you have 7 days worth of code instead of 1 day. So anyway, we're done. We tested it. Looks like everything is good. I'll put ran a game test to verify everything is working as it was. Seemed to be working 100%. Okay. So we ended up actually stopping at, basically we'll just say 9 o'clock, which is the solid 2 hours. So we actually did get our 2 hours in, which is really what I would like to get, at least 2 hours And this is not the 26th, this is the 28th. So there we go, 7 to 9, 2 hours. We did pretty good. I'm happy with our progress. I'm gonna go ahead and call it quit, and I'll see you guys next time, which will probably be maybe tomorrow, maybe not. Usually don't code on Sundays, but I might make an exception because I'm just getting my feet back in the water. I took like 25 days off coding because of peak season, so like I have the itch to continue to code and stream. It's like fresh, you know, because I took so much time off, so I may do it tomorrow. So anyway, have a good night. I'll see you next time.